Hello friend, myself Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. We are continuing with our multi-threading topic. In this session, we are going to talk about some priorities, methods, and some special thing about thread. Now, what is thread priority? Now, if you can recall, during the life cycle, we discussed something called as yield method. And what I said was if a thread is in running state, and if high priority thread comes and requests for processor, then the currently executing thread will relinquish the control of processor or voluntarily leave the control of processor using yield method and will directly go to runnable instead of block state. So it means that threads are assigned priority. Now it goes like this. See, the priority of a thread ranges in the constant value from 1 to 10. So the minimum priority that can be assigned to a thread is min underscore priority. It has constant value 1. So I can directly write priority, set priority. Like if T1 is a thread object, I can write T1 dot set priority as 1. So this will assign a priority to the thread. Or if I want to, if I want to assign it 10, I can simply write 10. If I don't want to write these numbers, I can directly write T1 dot set priority min underscore priority. So you may write the values, or you may write these, or you may use these constants, min underscore priority and max underscore priority. Now, but you may ask me a question, okay, up till now, we simply created a thread object, thread T1 equal to new thread, or when we extended a thread class, A1 equal to new A. We have not specified the priority of a thread. Now, if you're not specifying the priority of a thread, then the default priority assigned to a thread is norm underscore priority with a value 5. So ideally speaking, a thread with more priority value should have more control on processor, but unfortunately it doesn't happen. So, but still we have a concept of thread priority. Now, so just like the way I discussed, a thread with higher priority ideally should be more important to a program, and processor allocation should be more to it. But this priority of a thread actually cannot guarantee the order of execution, and it is very much platform dependent rather than depending on the priority. So we should not be of the assurance that if a thread is having high priority, so it will execute first and then thread with the lower priority. Because if this happens, so then again we are against the concept of multi-threading, where we never wanted a thread to wait. I mean, I never see if a thread is having high priority and somehow it is waiting, or I mean, got into wait state, and unless and until it completes, the thread with lower priority will not execute. So we don't want this to happen. So basically it depends on platform. Now, how to create a thread? We have already seen this. The first thing is, you can create a, we have already seen example in our first video. You can create a thread by implementing runnable interface and then overriding run method. And then you can create a thread object and pass it. Now this runnable thread object is object of class that implements runnable interface. So this is what it is. Here what we have, step number 1, create a class that implements runnable interface, override the run method, write thread logic into it, and then create the object of the thread class, pass to it the object of the class implementing runnable interface. And then what we are supposed to do, using the thread object, we are supposed to call run method. Using thread object, we are supposed to call run method. Let's see. Once the thread object is created, you can start it by calling, start method. We are not called run method. The run method is automatically called once the thread enters into running state from runnable state. So how do we activate a thread? Start method. So this is about creating a thread using runnable interface. Now the second way is, I mean, this is pretty simple. You create a class that extends thread class, override run method, and it should be public void run in both the case. And then you simply call start method. You just have to call the start method and the activation of the thread starts. So this is, I mean, these are the methods using which you can create thread. Now this is simple example. So in this example, we have used both. So you can see that here we have a class A that extends thread in the run method, like 10 times it displays hi every time with delay of 500 millisecond. Class B implements runnable. So they're like we are creating thread using two different methods. Here also from 0 to 10 it prints hello, there it prints hi, and every time there is 525 millisecond delay. I mean that can vary. Now since class A is extending thread class, so class A object will create a child thread object. But B will directly not create child thread object. For B, we need to create another thread object T2, and we will pass the object of this B that implements runnable interface. We'll pass it here. And now A1.start will activate A thread and T2.start. I cannot write B1.start because B1 is a class that implements runnable and do not extend thread. So this is a simple example. So output will be like hi, hello, hi, hello, hi, hello. Depends. I mean, it may be sometime 2 time hi, 1 time hello, 2 time hello, 1 time hi. Like the way it is very difficult to predict the correct sequence. However, we can do so using some methods like we can wait and notify. Then, but then wait and notify will be like forced serialized. We are like synchronizing it forcibly. Now, this is the order in which the control executes. Uh, it's like control from JVM. When we call start method, it's in run. See, when the execution starts, my main thread executes. And for child thread, when we call start, child thread A execute, which can call another child thread. And then, however, we can always switch the control. They can always switch the control between themselves also. So it's not necessary, but this is the activation flow. Like main thread will be activated first and then the child thread will be activated. This is how the work goes, the flow of control goes. Now, I would like to discuss some methods of thread class here. Suspend. Suspend is a method. I mean, these are some methods of thread class. So, I mean, yeah. Suspend method put the thread in suspended state. It is in block state, and we can regain the thread by using resume method. So resume method is to resume a thread. Sleep method, long millisecond. Long means it's a long time because we can specify millisecond with really large values. It can put the thread to sleep for specified time period using sleep second, where time is in millisecond. If it re-enters the runnable state as soon as the period has elapsed. So, and it is capable of throwing interrupted exception. So we always write this sleep method within try catch. If you're not writing within try catch, then you must write it into throws list of the method. So we have seen suspend method, resume method, and sleep method. Now let's say notify method. If a thread is blocked using wait method, see the method causes the current thread to wait until the further thread activates notify method. So if a thread is blocked using wait method, it can be regained using notify method. Notify method wakes up the first thread that called wait on the same object. So if the first thread that has called wait on that object due to some event to occur, now if that event occurs, then we can notify that object using notify method, and stop method, it kills the thread and basically removes all the resources allotted to the thread object. So these are the methods that we have seen for the thread. We have, okay, so this was about few methods of thread class. We are yet to talk about synchronization in thread, and we will discuss this in the next video. for detail about these thread methods, you can always refer Java to Complete Reference by Herbert Schuld. Thank you very much.